Okay, so again, just for simplicity's sake, we're going to continue with our hypothetical example of comparing the heights of men and women, right? We're just going to assume that women are X, men are Y, and then our experimental variable here is sex. So just keep that in mind in the back of your head as we're progressing through all this math and visualization of data charts. So again, our t-test calculations are being conducted on the assumption that H null is actually true, okay? And this right here is the null distribution. You'll find this on the top right-hand corner of page 100 in your manuals, and over a big chart of numbers. This is just a crude illustration of that, right? And so this is what's called the H0 or the Null T Distribution. This is a mathematical representation of all the possible scenarios of the differences between treatment X and Y. It's a representation of all the different possible t values, assuming that H null is actually true, okay? And what we want when looking at our t distribution chart, which is here, we want the differences between our two treatments to produce as large a t value as possible, because the larger the t values are, the further out they will be on one of these two tails, okay? And we're going to go over the difference between one and two-tailed hypotheses in a second. But for now, we're just sticking with the one-tailed hypothesis, right? Which is what we have right here, okay? So in the sciences, most of the time, what is considered a cutoff for statistical significance is this mark right here, 0.05, or to think of it another way, being on the 95th percentile or more extreme within our null distribution. So again, assuming that our null hypothesis is true, it's just an assumption, right? If you get a t value that's so extreme that it's at the 95th percentile or rarer, the thinking goes that, okay, we're so far out on this tail of this null distribution, this is such an unlikely occurrence. If you have these are essentially probability values, right? So if you're in the 95th percentile or higher, the chances of getting your t value, which again, our t value was 1. If your t value is this far out on the tail of the t distribution, then the thinking goes, it's so unlikely to occur that the null distribution might not be true, okay? So now, if you'll recall, our degrees of freedom were 6, and so now we can come over here. We can now go down to this the tabular representation of this chart. You'll note that here on the far left-hand column, in the bolded numbers, those are our degrees of freedom, okay? And these values at the top, 0.4, 0.25, 0.1, 0.05, these are all probability values. These are just like the tick marks on the far end of the tails that I illustrated over there, okay? That's just a bigger version of what's going on here. So the first thing you need to do is use your degrees of freedom, which again, we have 6. So we go down to 1, 2, 3, 4, 5, 6, and then you go to the right, all right? These are tables full of critical values, right? So you got to find the critical value that's under your probability cutoff, which in this class is going to be 0.05. So it's going to be in this column. So starting at the row of 6 degrees of freedom, we're going to go, okay, all right, over 1, 1. Okay, we didn't even make it to 0.05 because our t value is just 1, all right? And because of that, that means, because we did not even approach 0.05, that means this result is likely not significant.